This video will demonstrate how SnapGene makes it easy to simulate CloneTech's infusion cloning method. Infusion cloning is ideal for making seamless gene fusions. SnapGene has flexible options for infusion cloning. I'll focus on the most straightforward and general approach. My goal is to fuse a fluorescent protein gene to the end of a yeast gene called Sec21. The fluorescent protein gene is ACGFP1. This plasmid carries a 3' fragment of the Sec21 gene. To simulate the cloning, I choose Infusion Cloning from the Actions menu. I then choose Insert One Fragment. The Infusion Cloning window opens to the Vector tab, which automatically shows the plasmid that was visible when I invoked the command. Here in the box on the right are simple instructions for the procedure that I'll follow. Let's switch to Sequence View to take a closer look. When I scroll down, I see the stop codon of Sec21. I want to replace this stop codon with the GFP gene, so I click on the stop codon to select the region to be replaced. Now I click on the Fragment tab. As the source of the fragment to be inserted, I choose the plasmid containing the GFP gene. When I scroll down, the GFP gene appears. I click to select this gene. The selection begins at the start codon, and when I scroll down further, I see that the selection extends to the stop codon. Let's switch back to Map View to see these selections. Note that the GFP gene points in the forward direction, but when I go back to the Vector tab, I see that the Sec21 gene points in the opposite direction. So I return to the Fragment tab and click this button so that the GFP gene will be inserted in the flipped orientation. I need to choose primers to make PCR products that will overlap for the infusion reaction. To design the primers automatically, I switch to the Product tab and press Choose Overlapping PCR Primers. I'll use the default values for TM and for the number of overlapping bases. When I press Choose Primers, the infusion product appears. At this point, I could finish the cloning, but let's go back and see how it worked. I click on the Vector tab. It shows me that SnapGene chose 2 primers that point in opposite directions to amplify the entire vector except for the Sec21 stop codon. Now I click on the Fragment tab. It shows me that SnapGene chose primers that amplify the GFP gene. These primer bases displayed in red are the 5' extensions that will create an overlapping PCR product. I click back on the Product tab. The default name of the cloned product is fused, but I'll change it to Yiplac 211-Sec21-ACGFP1. Now when I press clone, the product appears. To see the fusion in more detail, I click on the Sequence tab. Here are 2 of the primers that were used for infusion cloning. When I scroll down, I see the other 2 primers at the junction between Sec21 and the GFP gene. When I click on the History tab, I see a graphical overview of the procedure. Finally, when I click on the Primers tab, I see all 4 primers listed. I want to order these primers, so I'll export them to a text file. For that purpose, I click on the first primer to select it, then shift-click on the last primer to select the whole list. Then I open the Primers menu and choose Export Selected Primers. I'll save the text file to my desktop. Now when I double-click on the exported file, I see that the primer names and sequences are ready to copy into an online order form. That's all there is to it. If you're already a fan of infusion cloning, you'll love how SnapGene takes the effort out of designing the primers. If you haven't tried infusion cloning, SnapGene can show you how easy it is to create the constructs you need.